Hi, good morning to all of you. Today we are going to see about the design for manufacturing, what is design factors, what is a systematic working plan, and what are the factors which are going to influencing the design as per Dr. Ogerberg concept. Okay, so these are the things we are going to see today in the design for manufacturing and assembly. Design factors. A rational working plan of the drawing office is shown. It should be purely intellectual creative design, and the organization measures should be there, and sequencing and distribution of the designing task. Starting the problem, what is the basic of a problem and how we need to work on the problem, and what is the suitable methods to manufacture the product, and what are the design which are being involved in these things. That all the very important things which we need to focus on doing on the design factors. Then plan of large complex parts like casting, large forging, requirement of tools, jigs, fixtures. These plays a major role in terms of the manufacturing of all the components which are requested. And after that, the smooth and trouble-free development can be done using these types. So next after that, designer's work plan. This is very important. What is a working plan of a designer? It is like a rule or a regulation which need to be followed. Exact determination of the customer requirement or the problem posed. Suppose if the customer is telling some problem, the designer need to understand what is the given problem to him, and after that he need to give the respective solution for the problem. Otherwise what will happen, what is the expectations cannot be stated, because of that the problem may occur. Next, after that, checking the order feasibility to carry out in the own firm, or it should be outsourced. Or for example, if I am having only a lathe machine or a milling machine, at the time what are the jobs which I can do in my own resource need to be planned. Otherwise, if I am going to do outsource of some product which is required for the product, then we need to include that also as a cost. At the time, what is the problem? Suppose if I am doing a product outside from my firm, what will happen means I need to include the basic component cost, then after that the transport cost, etc. So these are the things which need to be included, and other overhead costs also which may be included over there. Then supply of all the data for preliminary work. What are the data which is required, like data sheets, quality assurance plan, detailed design of the product, and all the preliminary work, 2D drawing, GA drawing, P&ID drawings. These are all the required to carry out the design through. Then after that, possible solution, like you need to, as a designer's work plan, he need to tell multiple solutions for the customer. These are the methods I can do this object like that. He need to tell multiple ways. In that, which is the best one, he need to find out, and you need to give the proper solution for the thing. Then methodological working out of the overall design. What is methodological design? First, which component, second, which component, third, like that we need to sequence all the orders like a plan, and after that only you need to complete it and you need to give it. Then splitting up of the overall design into groups. For example, I will take this as an example in a thermal power plant. In a thermal power plant, what are the different areas are there? Civil work is there, mechanical work is there, electrical work is there. In that, each divisions we have one manager or engineer or a director. At that time, what will happen? All the works need to be divided and given to them accordingly. The reason is then only they can plan their own things. Before installing the machine, all the civil works need to be completed and the electrical works need to be given. That is called methodological working out of overall design. It need to be split up into small parts, the entire drawing based on the drawing numbers. Then detailed designs. Detailed design taking priority into the account. What is the meaning of detailed design? Means each and every component, what is the inside component it is available. Like that we need to have a detailed design on it. Like each product, what is the manufacturing, what is the material of construction of the product, what is the dimension of the product, like that each and everything it need to be given there. Then after that, consultation with work or production planning. Next is the major division. In the production plan, how they are going to planning the job per day, how many job they are going to work. For example, whether he is going to do the entire product in casting or in molding or fitting type of things, or like that welding, machining, etc. He need to plan accordingly what type of thing which is going to do, forging, etc. Then product design, assemblies and component. If the product is being manufactured, whether you are going to assemble it and you are going to transport it, or in the site you are going to make the assembly. That is very important. So product design assemblies. So if some component, what will happen, they can assemble there itself. But some components, what will happen, you need to buy all the raw material and you want to assemble in the site itself. Like that also it is possible. Next, after that, consultation with works, possibly with customer also, regarding the suggestion for modification. Suppose if the design is coming one way and after fabricating there may be any changes, at that time you need to inform that to the customer also, and you need to rectify the drawing. That is called as the as-built drawing. After the approved drawing also, there some changes may come. That is called as-built drawing. Then after that, production of necessary work drawings. For example, each and everything already whatever a product is done, the designer will communicate his ideas only through drawings and the writings. So production, what are the drawing is required, we need to supply it to them, all the different type of drawing, assembly drawing, product drawing, etc. Then inspection will be carried out for, it may be for the entire product or it may be for a batch. Like that we can tell. Then testing, evaluation of the test results, whether all the things are coming correct, or if it is changing. For example, if someone is manufacturing a pump, the basic critical characteristic is the flow rate and the pressure which is developed over the pump. Like that they used to test all the things and they'll give the test certificate for it. And after that, obtaining customer's verdict, in service possible suggestion for improvement. Suppose after putting it over there, suppose the calculations may change or any changes may come, at the time we need to include that also. This is how the designer's work plan will be there. Next, what are the factors influencing the design? According to the Dr. Ogerberg, the task imposed directly by the customer requirement, and next is the imposed by the problem of the manufacturer in the shop. So these both we need to know. So first is the task imposed by requirement, next is the task relating to manufacturing area. That is required, first one is the required action. Then mechanical loading, what are the different type of loading, what is the action we need to take, that is the by requirement. Then climatic influence, suppose if you are going to put a power plant over in Chennai, it is different. If it is in a seashore, it is different. If it is in Rajasthan, it is different. Like that, each and every places, the climatic influence, how it is there, the basic climatic condition. Then chemical influence, what type of chemical you are going to use in the pipelines or in the remaining things, that is very, very important. Next, after that, mechanical environment conditions. Around it, how the condition is there. Near ocean, the condition is different. If it is in a desert, the condition is different. Then size of the entire product. Then weight of the entire product. Then after that, fitness for shipment, whether how you are going to ship the entire component in the assembly mode, or you are going to reassemble in the site after the testing. Then handling from one place to another place, you are going to use a crane or what type of product to handle the things. Next, maintenance plays a major role, like how you are going to maintain the equipment, weekly service or yearly service, or this much time of work you are going to do the service, overhaul. Then after that, economy of energy consumptions. Then how you are going to the energy level of each and every component, that is very important. Then service life, how much time your product is going to work, reliability. Then operation cost of the machine, appearance, how it looks, and delivery date, which is very, very important. If you are committing with the delivery date, on the same day you should able to distribute to them. Then quantity required, how many quantity required and what are the spares required for this. These are called as the task imposed by requirement. Next, after that, task related to manufacturer, what is the working principle of the component, what is the mechanical loading of the component, quantity required, it is closely the same. Then condition of the material, how it will be given. Then coating, suppose if it is if some coating is required at some points due to the friction, so at the place what type of coating you are going to provide over there. Then material availability, whether the raw material is directly available to us or we need to purchase the material. Then after that, manufacturing method, like I told already, the different type of it can be additive manufacturing, it can be a constructional solid geometry, or it can be a destructive solid geometry, or any type of manufacturing methods you can use over here. Then after that, labor required, very important, how many labors which are required for each to do your product. That is very very important. Next after that, machine equipment. What are the machine equipment you are having in your in-house, or what are the machine equipment it is required for you to buy from outside? That is very very important. Next after that, limits and fits. It is like if you are doing any product, it should come as per the given the tolerance in the drawing data book. Then after that, surface finish. What type of surface finish the customer is expecting, you need to give that. Then jigs required for it, and fixture as a holding tool. These are the requirement. Then gauges and inspection facilities. That there the calibration plays a major role. How you are calibrating your things, and what type of fixtures or what type of gauges is required to measure that. Then delivery date of the component. Already I discussed the cost for manufacturing. In that only you need to keep the buffer for your profit also. So if the cost of the product is going very high, then it is very tough to deliver for you at the time you may under a product. Next, national standards, work standards item. What is the national standards which is followed over there to do the product? Next, material standards, each and every like ASTM, ASME, APA, there are the different standards. Next is the scrap utilization. Out of the scrap, what you are going to do in the next way, that will be helpful for other the other product. Otherwise, entire things will be as a scrap, mean there is no use in it. Then patents. You can apply the patent for your manufacturing method or your design or anything which is there. Then use of existing product. Suppose if the product is existing, how you are going to service it, we are going to give it to them back. Like that, the existing product also you can make the modification. Then clarity of design worker. Okay, in this what we are going to see, 4 different things. That is the same thing. It is divided as working principle, material form, manufacturing form, and design form. This is all overall. It is the same only. Next, what is the interconnection here? Cost. Everywhere cost plays a major role, because based on that only our economy and everything is moving, and the product cost, etc. Like, so cost is coming here in the middle of all the things. So cost is very very important. Next is the working principle, design, manufacturing method, material. So these all are interconnected, but what is at the center? The cost is at the center. Next, systematic working plan of the designer. What is the systematic working plan means? So in the systematic working plan, the important thing is how we are going to work with the existing techniques. That is very very important. In that, the methodological planning, practical planning should be there. So first what we need to do, we need to understand study the problem and prepare a freehand sketch of the design and the principle of action, then selection of material, and finally how you are going to carry out the entire process. For this, the economy also plays a major role, and you can make several arguments for this, how you are going to make the methodological plan and etc. So that is also is very important over here. So this is the systematic working plan. Here it starts with the problem. First is the basic design, next material, next manufacture, next form, next overall cost. This is the working plan. So in the systematic working plan, first what we should know, exact formulation of the problem. If the problem is not formed properly, we cannot do the remaining works in a proper manner. If your problem is very correct, then you should able to explain your problem. This is my problem, and after that, based on that only the solution can be given. Then setting out of the solutions capable for the using the basic design and optimum method. Then selection of the most suitable material. What is the material is required? Then production cost, the production of the engineering product. Then decide of the most appropriate form design and ascertaining overall cost. So this is very very important as a systematic working plan. Okay, how the final form will come, and how the shape the designer, first what are the assumptions he is making, and how he is running through the entire project, material, manufacturing, form, and what are the economic factors which are being involved here. That is also is important. If suppose if it is unsatisfactory, you need to re-examine the material, manufacturing, form and cost to make the better design. Now If the overall cost is going to increase, what it will happen over here? If the cost is not satisfied, then you need to go back to the form, then you need to go back to the manufacturer, then you need to go back to the material, then the entire design will be changed. So while you are dealing the problem, what is very important means how the cost is being involved. So if the cost is very high, you cannot make the marketing out of it, so that plays a major role. So the problem to be solved, start can be made on the design solution of engineering problem. It should clarify, or it should give a proper clarity on the solution dealing with an order. The demands what the customer is making, it involved as a major thing for us. So the problem to be solved, this is the problem which need to be solved for any product. That is the action required. Then after that, mechanical loading, already we did about this. Climatic influence, chemical influence, mechanical environment, size, weight, fitness, handling, maintenance, and overhaul, economy of energy consumption, service life, reliability, operating cost, appearance, delivery date, quantity record, and freedom from noise. What does it mean? The noise which is made, this is a new thing in the machine. It should not be very high, and it should not spoil the entire atmosphere also. Next, types of the problem to be solved. From the customer order, these are the problems, and from work order, these are the different problems. From the customer orders, if you take ready-made product can be there, ready-made product with modifications. Next, complaint about the machines which previously supplied, then repairs, new design, and improvement of the design. Same like that from the work order, further development, new design, and invention. So two classes of problem which were available for us, so these need to be solved. From customer order, what are things like things which need to be solved are like adequately the advertisement recommendation of what need to be done, and after that exactly formulating the problem also will help us to understand the things. Work order, with respect to the work order, how the part is going to be designed, and how after the sales and service of the part, and what are the different efforts which are made to make the new design, and after that economical consideration is important over here, and policy of interchangeability means is very important thing. Suppose all the bolt and nut of a component which need to be made in the same size, the reason behind it is it can be replaced at any time without any further delay, so that is very important. Next, after that, various influencing factors like accuracy of the action required, then positive rate, simplicity of layout, low rate of wear joints and guides, low energy consumption, small inertia effect, and low manufacturing cost. These are the influencing factors in any design. Next, the materials which are used. Factors determining the choice of materials. Most of the designer has to face, because material plays a major role. In a place of steel, if you made some alloys or anything, you are answerable for it. See, because the material is going through all the things. If the material is going to fail, the entire design is going to fail. The design itself can become a failure, or because of the material also the design may be failed. So very large number of factors need to be considered. So many decades ago, this is not much complicated one, but today it is being complicated. The reason is we are doing so many optimization and so many methods to do these things. Then modern technologies which is very possessing diverse properties like steel alone, 100 of unalloyed grades, several alloy grades, like that it is being used. As far as the molded plastic for example is concerned, we are in the still beginning stage. So the people need to recognize the advancement of a design is not purely by the design alone, but it is also with the material which we are going to manufacture also. Next, very important chart. Very important chart. Here the properties of materials are being discussed. So in this, the materials can be generally classified as 4 categories. One is physical, second one is mechanical, third one is technological, and fourth one is chemical. In that physical, what is the specific heat of the material, melting point of the material? For example, lead used to in the room temperature itself, it will go for a creep, so melting point. Then thermal conductivity of the material, how it can conduct the heat and etc. Then coefficient of thermal expansion. Next, electrical conductivity, intensity of magnetization, saturation, then remanence, corrosive force, then permeability. These are the important physical parameters which need to be seen in any material before you are designing, and as a designer you should be able to know about all these things. Next, mechanical related: specific gravity of the material, tensile strength, compressive strength, using of UTM we can test this, and shear strength, double shear we can test, then bending strength of the material, then fatigue properties, then torsional strength, buckling strength, elastic limit, modulus of elasticity, impact test figures, coefficient of expansion, hardness, high temperature properties, wear resistant and sliding properties. These all. For example, tensile compressive is the maximum which we use. Theory of failure we will use to find out the what is the tensile, what is the compressive, what is the shear, etc. Then what is the yield point of the material, then bending, compression force we can apply, like that we can test for each material. For example, if you take a brick, we will do only a compression test, how it is it can withstand the compressive, but we will not go for any tensile strength. Next, technological. Technological means the method which you are going to manufacture the things. In that it will come as a castability, whether the material can be casted or not. Suppose some material will not be casted, so that is very important. Then forgeability, whether it can be heated and it can be hammered or not, that is very important. Capacity for being rolled, whether it can be rolled or not. Some material cannot be rolled. Then after that, deep drawing capacity of the material. Next, machinability, can we do the machining operation of these things. Then beltability, whether it can be belted. Some materials cannot be belted. Then suitability for bracing, shrinkage, surface properties. So these are the different technological properties which it need to be coming in the entire scale. Then after that, chemical related properties. Suppose if you are having a pipe, you cannot use a steel pipe to transmit the acids because it will go for corrosion. So we will use a different type of plastic pipe. Suppose if you are storing acid in a tank, you should go for the lining inside the things, like FRP lining, FRP tanks. You should have to store the acids. In the steel tank you cannot store because you go for a corrosion. Acids, bases, then oxidation, how you are showing the water, then oil, grease, petrol, soap solution, electrolysis formation. So these are the different things which lies with the properties and the technological properties. So these are the four. In a consolidation, physical is important, mechanical is important, technological is important, chemical is important. Then after that, the next one is manufacture. Avoid the following while you are going for manufacturing: heavy wastage of material. The material should not be wasted. Suppose if you are doing any component, you should not have any wastage out of it. Then reclamping of the work. If you are doing one part and if you want to clamp it again or something, that is very important to clamp. Then auxiliary equipment, how you are going to connect it. Then special purpose tools. What are the tools you need or you want to make or you are doing it. Then change of machine from one machine to other, how it is going to be getting changed. Then expensive of machining operation, how much operations it is required and what is the cost involved it, and finished operation, how it will appear. That is it. Then rejects. Suppose it is going to get rejected, what you are going to do as a next step, because we cannot throw all the manufactured component outside. If it is an injection molding, we can take it and we can put it again and we can go for manufacturing. But think about a machine machined product, we cannot do the same. Then difficult assembly. Suppose if the assembly is very complicated or it needs some certain steps and protocols, that assembly sequence is very important. How you are going to put sequence order first, second, third, like that, you need to be clear on it. So like that we need to be clear in the manufacturing technology also. So in the overall thing, we studied about the what are the design factors which are being involved. According to Ogerberg, what are the factors which need to be considered, and what is the systematic working plan of a design engineer or design, how it need to be done, and how the choice of the materials plays a major role, and what are the different type of material which is used, and what are the properties of material which we need to follow with respect to parameters, and what are the manufacturing problems. Always the product should be choice for materials and it should have a good choice for the manufacturing, and economically everything need to be right, because we saw in the previous slides that economy of the product is very important, because if the cost is very high, then it will not be sold out. So assembly sequence of any object, how it is being transported, etc., we gone through the different things. So as a overall consolidation, the design for manufacturing, designer role, choice of material and choice of manufacturing, and what are the technological factors which are involved over here about the materials, these all plays a major role. So we should be clear in this. Thank you.